Alright guys, welcome back. We're going to be solving another question in today's video, and we have 3 to the x plus x is equal to 30, and we're going to use Lambert W function in this one. So we solved the question in one of the previous videos regarding how to use Lambert W function in order to find these kind of equations, and in this one we're going to practice another equation using that function. So first of all, let's just do a quick review of the Lambert function. So what Lambert W function says is that when we have alpha times e to the power of alpha, if we do the Lambert function of this expression, we're gonna get alpha. And in here, let's try to make that alpha in here and do the same thing on the exponent. So what we're gonna do in here is that we're gonna bring x to the other side of the equation. So we will have 3 to the x is equal to 30 minus x. So x goes to the other side of the equation, and the positive turn to negative. So that's the negative sign in here. And in order to get rid of the 3 to the x on the left side of the equation, we'll divide this equation or each side by 3 to the x. And what we're going to get on the left side is 3 to the x divided by 3 to the x. Keep in mind that we know that 3 to the x is greater than 0, so we know that that's not going to make our denominator 0, and here we will have 30 minus x divided by 3 to the x. And we know from the laws of the exponent, when we have 1 over a to the power of b, this will be equal to a to the power of minus b. So basically when this goes up, we'll just have a negative sign in the exponent. We have the same scenario in here. We have 3 to the x. So on the left side, obviously we have 1, and on the other side, when we are bringing the 30 minus x to the numerator, we'll have 3 to the minus x, which is basically what we have in here. So now that we see that we are getting closer and closer to build that alpha, so we have this one in here, which is 1 alpha, but here we have minus x, and we have to figure out how we can make the exponent same as the alpha that we have in here. And we can see if we multiply this by 3 to the power of 30, what we're going to get on the left side is basically 3 to the 30, and in here we have 30 minus x times 3 to the 30 times 3 to the minus x. So from the laws of the exponent, when we have a to the b times a to the c, this will be basically a to the power of b plus c. This is our b, this is our c. So basically on the left side we have 3 to the 30 is equal to 30 minus x times 3. This time we'll have 30 minus x. So we are getting closer and closer to our Lambert W function. So we built that alpha, but the thing is we don't have e in here and we have 3, meaning we have to use something else in order to build that Lambert function that we're looking for. And from the laws of the natural log, we know when we have e to the power of natural log of a, this will be equal to a. So if you want to use that in here, e to the power of ln of 3 is 3. So let's just do that and put that in here. So 3 to the 30 is equal to 30 minus x times e to the power of ln of 3 to the power of 30 minus x. And from the laws of the exponent, when we have a to the m to the power of n, this would be basically a to the power of m times n. And what we have in here, this is our m and this is our n. So 3 to the 30 is equal to 30 minus x times e to the power of ln of 3 times 30 minus x. So looking at this, we'll see that our alpha is different now. We have ln of 3 in here. There's an ln of 3 that is missing on the back of the e. So if we multiply this equation by ln of 3, on the left side we have ln of 3 times 3 to the 30, and on the right side we have ln of 3 times 30 minus x to the power of e ln of 3 times 30 minus x. Now we have alpha here, we have alpha here. Now if we do the Lambert W function, from the left side we have a Lambert function of ln of 3 times 3 to the 30, and on the right side we have the Lambert function which would be equal to alpha, which was ln of 3 times 3d minus x. Now we have to do something for the left side of the equation because we have the Lambert function of 3 to the 30 times ln of 3, and on the right side we basically have what we have in here. And what we're going to do in here for the Lambert function of for 330, we're going to do 3 to the 3 times 3 to the 27 times ln of 3, and we're going to keep the other side derivatives. And here we see we basically have 27 times 3 to the 27, and we're going to keep the ln of 3 derivatives. Again, no changes on the right side, and here we're gonna use 27 times ln of 3, and instead of 3 to 27 we're gonna do what we used previously in here. So instead of 3 we're just gonna put e to the power of ln of 3, which will be to the power of 27, and no changes on the right side. And now we have our law of exponent, which would be basically 27 ln of 3 times e to the power of ln of 3 times 27, and we managed to build that alpha in here that we were looking for, which means basically 27 ln of 3 is equal to what we had on the other side of the equation, which was this one in here. So ln of 3 times 3d minus x, and we can cancel out the ln of 3, and the x that we would get is 3, which would be the final answer. So actually it's not that hard to guess the answer at the first place by just looking at it, but the main purpose of this question was to show the use of Lambert W function and the process of getting to that answer using this function. And yeah, that's pretty much it for this question. The other way to make sure that the x is equal 3 is the only answer is to graph the left side of the equation and see where it crosses the right side of the equation, and that's the other way to figure out that this equation has only one answer. So let me know if you have any other solutions to solve this, and you guys take care. I'll see you in the next video. Have a good one.